Good morning, everyone. Today I am going to take the lecture of Discrete Mathematics, chapter number 3rd. The name is the relation. So today's topic is relation matrix, diagraph, inverse, the complement. Okay. So what is relation? What is the definition of the relations? A and B be two sides, a binary relation, or we can say it simply a relation from A to B is a subset of A cross B. Okay, so suppose there is a relation from A to B. Here we write the capital and we read, consider here capital R, that means relation. So suppose capital R is a relation from A to B, then is a set of ordered pair where each first element from A and each second element comes from B. That means if we can say that the relation A to B, first element is from the set A and the second element is from the set B. That is, for each pair A belongs to A and A belongs to B, exactly one of the following is true. So for example, we write here the small a belongs to capital A and small b belongs to capital B, because we write here the ordered pair. So A comma B belongs to R. We then say A is related to B. Okay. And we write here A capital R B. Okay. Second one is if A comma B not belongs to R. That means we then say A is not related to B. Okay, so if R is a relation from A to itself, in this example, we write here the two sets, okay, A and B, and the first element from A and the second element from B. So if we write here a relation from A to itself, that means A cross A. So if R is the subset of A square is equal to A cross A, then we can say that is a relation of A. Okay, next is the domain and the range. We have already seen this topic domain and range according to our function, second chapter. Okay, so let capital and capital B be two sets and be a relation from A to B. Okay, so that is R subset A cross B. Why we write here R subset A cross B? Because R is a relation. And A related to B, that means what? The first element from capital A and the second element from capital B. Okay, so R is equal to A comma B. So A belongs to A and B belongs to A. So right here, if you have the two sets A and B, so R is equal to what? A comma B. A belongs to A and B belongs to A. Okay. The set of all first coordinator of R is known as domain of R. Okay. And the set of all second coordinates of R is known as range of R. So just like according to our second chapter, we have already seen in the function. Okay. So according to function, we write f such that A to B. Okay. So elements of A. So image is elements of B. Okay. So A is your domain and B is your domain. Okay. So here we write the A is your domain and B is your range. Okay. Next one is this is one example different from the domain and range. You can say that this is an example of the relation. Okay. A is equal to 1, 2, 3, 4, 5, 6 up to 20. Okay. We are given in a relation. Relation is what? Relation is x comma y such that x is equal to 3y. That means we are given in a set A 1, 2, 3, 4 up to 20. Got it? And we are given in the relation. Relation is what? Relation is x comma y such that x is equal to 3y. Okay. So what is the relation? Relation is that we write here always the ordered pair. Got it? So here the ordered pair is what? X comma y. Okay. So relation is what? And relation is what? X is equal to 3y. That means we put here the value of y and we get the value of x. So what is the relation? Relation is if we put y is equal to 5. Okay, so x is equal to what? 3 into 1, that means 3. If we put y is equal to 2, so x is equal to what? X is equal to 6. If we put y equal to 3, so x is equal to 9. If we put y equal to 4, so x is equal to 12. If we put y equal to 5, so x is equal to 15. Y equal to 6, x is equal to 18. Okay, but if we put y is equal to 7, so x is equal to what? 21. But 21 is not in your set A. Because of here, we are given in the number of elements from set A is 1 to 20. So if we put according to a relation, y is equal to 7. Okay, so x is equal to 21 and 21 is not in the element of the set A. So we write here relation only 1 to 6. Got it? Next example is x is a is equal to 2, 3, 5, 6. Okay, and we are given in the relation x is such that x divide y. And what do you mean by the x divide y? That means we divide y by x. Okay, so what is the relation? Because we are given in the set 2, 3, 5 and 6. So first one is, always keep in mind, every number is divided by itself. Okay, that means 2 divided by 2, 3 divided by 3, 5 divided by 5 and 6 divided by 6. Okay, so 4 pair is what? The relation is equal to 2 comma 2, 3 comma 3, 5 comma 5 and 6 comma 6. Okay, next one is what? 2 divided by 6, because if 2 is not divided by 3 and 2 is not divided by 5. So 2 divides 6. Okay, and 3 divides 6. So what is the relation? Relation is 2 comma 2, 3 comma 3, 5 comma 5, 6 comma 6, 2 comma 6 and 3 comma 6. Okay, next is relation matrix. What is the relation matrix? So see, if we have the set A and the elements is A1, A2, A3 up to AN. Set B, the elements is B1, B2 up to BN. Okay, and A and B are finite sets containing n cross elements respectively. Okay, that means the set A has the n elements and set B have elements. Okay, then A cross B will contain cross elements. Okay, so here let R be a relation from A to B, then R subset A cross B to represent R as matrix known as relation matrix, denoted by the capital suffix R. Okay, so here L R is equal to what? R is equal to L A J. That means A and jth column. So if we write here 1, if AI related to BJ, that means if we are given in any set and according to set we are given in any relation. Okay, we see here the 2 examples in the previous slide. So if we find out the relations, if relations are present according to your set, so you write here 1, A related to B. But if A not related to B, so we write here the 0. This is called the relation matrix. So this is the example of the relation matrix. So example A is equal to, we are given in the 1, 2, 3, 4 and B is equal to 1, 4, 6, 8, 9. We are given in here 2 sets. Okay. So A related to B if and only if B is equal to A square. Okay. So according to this question, we are given in the 2 sets. Okay. So set A at the 4 elements 1, 4 and is also 5 elements 1, 4, 6, 8, 9. And what is the relation? Relation is A related to B if and only if B is equal to A square. Okay, so then find the relation matrix. So what is the process? Process is that first we write here the relation. And what is the relation? Relation is B is equal to A square. That means we put here the value of A according to your set A, capital A. Okay. So capital A is 4 elements, 1, 2, 3, 4. So one by one, here the value of A according to the value of A down the set B. Okay. So here first we write here the relation. So relation is equal to what? If according to your set A, we put here small a is equal to 1. Okay. So 1 square is equal to 1. That means b is equal to 1. Okay. So 1 is present. B. Yes, 1 is present. B. So what is the relation? 1, 1. Because of b is equal to a square. We are given in this way. Okay. Next one is we consider the number 2 according to your set A. So 2 square, that means 4. So b is equal to 4. So 4 is present in your set B. Yes, it is present in your set B. So what is the relation? 2, 4. Next is here A is equal to 3. So 3 square is equal to what? 9. So your pair is 3, 9. Okay. Next is here A is equal to 4 because of set A 4 elements. 3. So if the 2, 4, 9. If we the A is equal to 4. So B is equal to what? So 4 square. 4 square, that means what? 16, but 16 is not the element of the set B. So here we use only the 3 elements 2, 3. So what is the relation? Relation is 2, 4, 3, 9. Okay. So according to this relation, we mark the relation matrix by the capital suffix capital K. So first in the row you write here 1, 2, 3, 4. The elements of the set A. According to your column 1, 6, 8, 9. Okay. So check here your relation set 1, 1, 2, 4, 3, 9. So this matrix here to check the relation 1, 1. So according to 1, 1 you write here 1. According to 4 you write here 1. According to 3, that means row 3, set A and set B 9. So 3 to 9 you write here 1. Places you write here 0 because of according to relation matrix. If AI related to BJ, so you write here 1. Okay. And AI not related to BJ, so you write here the 0. Okay. Next one is the graphical representation of the relation. Other name is the diagraph. Okay. So let capital B is a set. Capital R be a relation defined on A. Then can be represented by graph. Okay. So called diagraph or directed graph. The elements of set A represented by circles or points. These elements are known as nodes, vertices. So if A or B, that means A related to B, this can be represented by a loop around. Okay. And next one is if A or B, then this can be represented by an known as edges from A to B with an arrow from A to B. And the first one is A related to A. If A related to itself, so you write here the loop. Okay, and if A related to B, so you use the R or we use edges. Okay, so here this is example of the diagram. Okay, A is equal to, we are given in 1, 2, 4, 8. And relation is given by A related to B if and only if A divides B. Okay, then the diagram of the relation. So always keep in mind, if we are given in any question, given the any relation, So first you write here the relations. Okay. After that, you draw here the diagraph or directed graph. Okay. So what is the relation? Relation is A divides B. The elements is 1, 2, 4, 8. So we have already seen in the previous slides, every number divides itself. Okay. So first we use the 1 element. Number 1, first element. So 1 divides 1 divides 2, 1 divides 4, and 1 divides 8. Okay. So 1 comma 1, 1 comma 2, 1 comma 4, and 1 8. Next element is 2. So 2 divided by 2. Okay. 2 divides 4, 2 divides 8. So we write here 2 comma 2, 2 comma 4, 2 comma 8. Next element is 4. So 4 divides 4. So 4 comma 4. Next one is the 4 comma 8. That means 4 divides 8. Okay. And last one is 8 comma 8. So we have the relations 1 comma 8, 1 comma 2, 1 comma 4, 1 comma 8, 2 comma 2, 2 comma 4, 2 comma 8, 4 comma 4, 4 comma 8, and 8 comma 8. Okay, so according to this relation, we draw the diagraph. Okay, so diagraph is if any elements related to itself, so you write here the loop. Okay, so first we draw here 1, 2, 3, 4. 4 nodes, or you can say that 4 buttons. Okay, so 1, 1 itself related to itself, so we draw here the loop. 2, 2, yes, present in your relation. So 2, 2, we write here the loop. 4 comma 4, we write here the loop. And 8 comma 8, we write here the loop. Okay, so here first we find the 1 to 2. So here you write here 1 to 2. The direction is what? Direction is 1 to 2. 1 to 4. So again you write here the 1 to 4. Okay, next one is 1 to 8. So you draw here 1 to 8 and the direction of the arrow is 1 to 8. Okay, next one is 2 comma 2. So first you write here the self loop 2 comma 2. Okay, next is 2 to 4. So you write here the arrow 2 to 4. Next is 2 to 8. So you write here in the bottom side 4 to 8. 4 comma 4. So 4 itself related to itself. So we write here the loop. 4 comma 8. So you write here 4 comma 8 and the direction is 4 to 8. Okay, next one is the 8 comma 8. So you write here this loop 8, 8. Okay, so this is very easy example. We draw very easily in the directed graph, or you can say that the diagram. Okay, next is the inverse relation or converse relation. So if capital R is a relation from A to B, then the inverse relation of is denoted by R inverse is a relation on from B to A. That means if relation A to B. So converse relation is what? R inverse is related to A. So if R is equal to X comma Y, if we write here, so this is equal to what? Y comma X, where Y belongs to capital E and X belongs to capital A. Okay, so X comma Y belongs to R. And if X comma Y belongs to R, that means we can say that X related to Y. And Y inverse X, or you write here Y comma X belongs to R. Okay, so the inverse relation is also known as the converse relation. Okay, and hence sometimes it is denoted by R power C. Okay, converse relation. Next is the example of the converse relation. So if capital R is a further relation on set S, and set S is small f, B1, B2 and S. Okay, so here small f, father we consider here, and mother, B1 and B2 brother, and S1 is sister. Okay, and here we are given in the relation F comma B1, that means father to son, B1 brother, father to B2 son. and further to S1 dot. Okay. So the inverse relation of capital R can be what? Son relation and daughter relation. So R1 inverse is equal to what? B1F and B2F for son relation, and this is equal to what? S1F for daughter relation. Okay. Next one is the complement of a relation. So capital B2 non-empty sets a relation from A to B is defined as capital R is equal to A comma B such that A belongs to A, B belongs to capital B. Okay, that dash. So you read here the complement of is defined as H is equal to A comma B such that A comma B not belongs to R. Because of here we find the complement relation. Okay, that is A R dash B. A complement B if and only if A not related to B. Okay, so result is what? Result is R1 union R2 dash is equal to what? R1 dash intersection R2 dash. Okay, and second one is R1 intersection R2 dash is equal to R1 dash union R2 dash. This is the De Morgan's law, and you have already seen in your chapter number 1 set theory. Okay, so this is the basic definitions and simple introduction according to your chapter 3. Okay, so I will continue this topic in our next lecture. Thank you for watching this video.